Hi, I'm an old guy and I do maths, and here is a problem that a student of mine was given to solve, and she told me that she really had no idea about how to attack this. So let's see if we can solve the problem here. What we have is we have an arc of a diameter we as yet don't know, and we have a chord joining the ends of that arc that is 12 centimeters in length, and with the diameter that we have drawn through here to the point at which the arc joins the circle here, there is an angle of 60 degrees. I'm sure that's meant to be helpful, and we will see if we can get some help from it. So let's just see what it is we're dealing with. If I draw in a radius at 90 degrees to the diameter, what I see is that we are dealing with something that is more than 270 degrees. And our first task is to find out how many degrees this arc is. So how do we do that? Well, we know that this is a radius, and we know that this is a radius. So if we were to draw a third radius in, what we would know is that this and this, and of course this, are all of equal length, but this is what is of interest to me. So if these two lines are of equal length, then the angle that we get in here will be the same as this angle. It will be 60 degrees, and that means that this angle here is 60 degrees. This is actually an equilateral triangle. And from that we discover two things. One is that if this is 60 degrees, this little angle in here is 30. And if this is 270, then the total angle of this arc, which if we just draw it here, looks like that, that is 270 plus 30 degrees, 300 degrees. And from this equilateral triangle, we know that if that is 12 centimeters, that is 12 centimeters. So we now have a measurement for the radius. Now, so how do we find the perimeter of this shape? We already know that. Well, we use 2 pi r for the circumference of a circle, but in this case we have a 300 degree arc, and we divide that by 360 to get the portion of the arc that we're seeing here. Okay, well we can simplify this fraction, so this becomes 2 pi r times 5 over 6. So let's go to work. I'm going to make pi equal 3.14. We're just going to do it roughly. As you can see on my calculator, I have a button for pi. I could do that. But we'll just work this out roughly using fairly accepted standard for pi that you see in school textbooks, which is where this problem came from. So what have we got? We have got 2 times 3.14 times the radius, which is 12, and that gives us 75.36. Now we have to multiply that by 5 over 6, and that gives us 62.8 centimeters. Now, what's missing? Well, we need to add 12 to that. And the answer that we get is 74.8 centimeters. Now, if you wanted something more accurate, you would use the pi button on your calculator, and you'd probably get this to 8 or 10 digits, to 8 or 10 decimal places rather. But anyway, that's how something like this is solved. Now, I don't pretend that I looked at this and instantly went, aha, I know how to do it. I drew it a few times. I played around with it. I put in some lines here and there, and then at some point I realized, oh, if that's a radius, and that's a radius, then a radius from here to here will be the same length as this. Therefore, these two angles will be the same, and the third angle will have to be 60, so that they add up to 180, making this an equilateral triangle, and suddenly everything fell into place. Anyway, that's how you do this. Thank you very much for watching. I hope you found it useful. If you did, please like and subscribe, and I'll see you next time. Bye.